Thank you very much. Thank you for the invitation, Pere and thank you for being here to attend this talk. I'll try to make it some time, although it's a bit long, the presentation. It's on incentive, so it, I think, follows that the last question. And I'll try to go straight to the motivation. We all have heard about incentive compatibility when it comes to contingent valuation, but much less when it comes to other valuation instruments, especially on revealed preferences. Not much is said. Sometimes it's assumed that since it's revealed in a market, there is no room for incentive compatibility issues there. And I'll try to show that there is concern and that it can be manipulated. And I'll show some instances in this where this could happen. And the other area of not much research on incentive compatibility is other static preference instruments like choice modeling. And I'll try to show that those are also manipulable and subject to the study. So the presentation will focus on these two, on revealed and on choice modeling. I'll go first through some concepts and assumptions, and then I quickly go to the revealed preference area, and then I move to the static preference area. And in revealed preference, I'll try to show a field experiment where we set it up in order to be very obvious that it could be manipulated in favor of the respondents. And I'll try to see what, when it's obvious, what happens. And a lab experiment with choice modeling where it's not that obvious that it could be manipulated, and I'll try to see what happens here and then compare both results in the conclusions. So that's the plan for the talk. So let's start with some concepts and terminology. First, incentive compatibility is an area of concern in mechanism design. So valuation can be seen as an instance of implementation of social choice, so what's called implementation mechanism designs, where you get some messages from individuals, from agents, and out of the messages you make a social decision, a social choice. Okay? So valuation would be a way to get the values, and then there is a decision rule to get the outcome. When we are in mechanism design, we study whether the mechanism is incentive compatible or not, or another way of saying it, if it's individual can be manipulated, is it manipulable? The definition of incentive compatibility is the standard one. And a mechanism is incentive compatible if no individual, by misrepresenting his or her preferences, can take advantage of the social outcome of the mechanism, of the decision. So if even one single individual, by lying, by misrepresenting, by saying something different to the true preferences, can end up with a better result than telling the truth, then we say this is not incentive compatible. It's manipulable. Okay? So that's the idea. And if it's manipulable, in theory, then still we have to see whether in practice people behave strategically or not, which is two different things. There are two different things. One is a theory, and the other one is whether this is relevant in practice. And that's what we'll try to see today, whether when in theory something is manipulable, what in practice we see that people manipulate or not. Okay, that's the idea. And when instead of a mechanism design, the mechanism is direct, we are in social choice, and then instead of incentive compatible, we call it a strategy proof. But it's the same, like referendum, like as you said before in the question. But it's the same definition, so it doesn't matter much the terminology we use. So the main assumptions, I only go through the main ones, which are very few. First, the exercise has to be consequential. So people have to believe that the answers will result in social choice, in some outcome. Okay, so it has to be consequential. Otherwise, we don't know what to study. Okay, so first it has to be consequential, and notice that not only aesthetic preference valuation can be consequential, also reveal preference can be consequential. Second, data have to be collected through statements, like surveys, as Bengt said before, usually through surveys. And this would include secondary data. Maybe the data we use in a travel cost or in a hedonic price exercise came from, was collected by someone else for a different purpose. So we have to look whether in the original purpose it was consequential and could be manipulated there. And I'll show you some instances of that with the real estate market in Spain. And then the last subject, this last assumption I put here is that we expect individuals to be rational. So when they can behave strategically, they will behave strategically. That's only an assumption for the analysis. Okay, we'll see whether people engage or don't engage later on this strategic behavior. So let's start with the reveal preference area, and then we move to the social choice. Hedonic pricing, we know that it could be influenced if it's stated somewhere. If they ask you in a survey how much did you pay for the good, saying you pay more, then the attributes of the good in a hedonic price exercise would appear as more important, as higher value. Or if you ask for the characteristic of the good that you get when you bought the good, you can manipulate there as well. Let me show you an example on the real estate market in Spain. Next to where I live, there's neighborhood going north from where I live in Barcelona, in Belterra, where the Autonomous University is. There is this neighborhood of high-rise apartments, flats of apartments. Okay, it's a low-income neighborhood, and all the flats there in this subdivision, all the flats are rent controlled, are actually price controlled. They cannot be sold unless there is a very special circumstance, and when sold, there is a cap on the price. Okay? So last time I checked, I think it was something on average, because there are 3 sizes of flats, on average was something like 90,000 euro a flat. Okay? But if you go to the neighborhood and you walk around and look at the real estate agents and look at the windows, the price of the flat is 200,000, in the old days was 300,000, 400,000, but cannot be sold for more than 90,000 by law. Okay? So when you buy, you put a part in B, in black, in cash, and a part that it's official. Okay? So if you use data like that, you end up with 90,000s, not with 200 or 300,000s. So even if it's secondary data and it's a market approach, reveal preference, you can end up with some incentives to misrepresent the data that you are using. Okay? And that we'll see later on in a case that I'll explain about. Similar in travel costs, we can influence, as we know, saying that we started the trip from farther away or from closer, or that the number of trips is more or less than what we actually did, and this would influence on the end result of the travel cost. And let me give you 2 examples, one very quick and one I'll give you some more detail. One comes from my university. And my university, the main campus, which is outside Barcelona, was served by a train line, okay, and had a station there. There's another company, the state company, that runs another train line that was that had a stop in the next town to the university. So if you took this other line, you had to walk 40 minutes or take a shuttle bus to the campus. Okay? We convinced the National Rail Company to extend that with a second station, a station for this railway line, the second railway line, to campus. So they would have a campus will be served by two different lines, two different companies. Okay, so the company said, well, let's study that. So we'll do a market prospect. Okay? We'll ask students or people at the university whether they would use it or not would use this station. So before doing the survey, the word came around saying if you are interviewed, say that you are going to use the line, and if you ask how many times, say more than you otherwise would actually use it, because then you get a more likelihood of getting the train, and we did get the train at the end. Okay, so sometimes maybe incentives are not clear, but if you are told, then maybe people will behave strategically, like in this case. And another example is a survey we did for Barcelona Zoo to look at the recreational value of visitors to the zoo. We did that with Veronica Ferreras from Argentina, and the paper is already available online, although this summer will come up in tourism economics, so you can already check it from there if you're interested. We applied a standard travel cost method, very standard, individual travel cost method, to people that at the exit of their visit to the zoo, and we asked basically for the number of visits over the last 5 years and the cost, where the origin, and so on. But the variable I want to focus on is we ask how many times did you visit the zoo over the last 5 years. Some visitors came from the province of Barcelona, some people came from farther away, and so those that live in the province of Barcelona, those we got a special treatment with a split sample randomly assigned. So every time we found one in the province of Barcelona, we would interview them having either subsample A or subsample B. Once a sample A, next a sample B, next a sample A, next B, and so on. So sample A, the script, the questionnaire, would read before the number of times that being asked the number of times that they have visited over the last 5 years. It would say, the province administration studies future discounts for residents in this province. Depending on how much residents use the zoo, then the discount would vary. If in the last 5 years, on average, the number of visits from the people that we are studying, from the people we are surveying, is less than 2 times in 5 years, okay, then it's no discount. So if you only come once, on average, no discount for anybody. If on average people come between 2 and 5, every visit in the future will have a discount of €3 if you are resident in the province. And if the average is 5 times or more, once per year or more, then it's a €7 discount that will be implemented for everybody that is a resident in the province. Okay? Subsample B, skip this part. If you ask subsample B, nothing was said about that. Okay? So we wanted to make very obvious there was an incentive to lie. So what do you think would be the outcome in the number of trips over the last 5 years between an A and B? Well, as you probably would expect, the average number of trips for those from A, randomly assigned, was significantly higher than those coming from B. So especially in the less than 2, okay, only 1 trip. it was dramatic, something like 7%, 22%, or 24%. So very, very different. Almost no one went only once from A, but many people went only once from B when nothing was stated. So when it's consequent, then people may lie. And if we use this data to get the consumer surplus of the recreational value of those visitors to the zoo, then we have a result that is different. If we use people from A, the consumer surplus is much higher than if we use people from B. Okay? So this is manipulable, and we show an instance where it's very clear that people could realize, and then if people realize, people seem to follow that, or enough individuals seem to follow that to force the a different decision from what would have happened if they didn't realize the incentive. So this was the idea for review preference, to show that this is also vulnerable to manipulability. The second case was a lab experiment on aesthetic preference. This was implemented at the National University of Colombia in Bogota by Olga Manrique. And this is a paper in progress that we are writing now. We interviewed under certain conditions. One of the conditions was that individual preferences were private. Okay, I'll explain that in a minute. And the cost of the public good was unknown, but there was some information on what was going to be this cost. I'll show you in a minute. It will become clear. The implementation rule was publicly known, so everyone knew what would happen with the answers. And we used the mean outcome rule. The mean outcome rule means that if the mean social value is higher than the cost, then the good will be provided. If the mean is lower than the cost, then it's not going to be provided. So very standard up to here. The payment amount collected each individual is the same, and that's important. Okay? The payment is not related, is not coupled, does not depend directly of how much you are willing to pay. I'm willing to pay a lot, he's willing to pay a little. If it's implemented, I'm going to pay the same that he's going to pay. Okay? That's quite a standard, but this is important, these characteristics. Although it could be relaxed and would still have the same result. But it's important here for reasons I'll discuss in a minute. We used a variant of choice model called contingent grouping. You can see the contingent grouping is sometimes used in marketing as a procedure before you go to a full ranking, and consists of stating which alternatives are better than the status quo, which alternatives are worse than the status quo. So when you see an alternative, whether you agree with it or you don't agree with it, if it's too expensive or it's reasonable price, okay? You would like it or you would not like it. You only have to group that, nothing else. Okay? That's the idea. You can see the full development of this variant in Raoul Bray and others in Resource and Energy and Economics. And that's what we used, this variant. But we could use any other variant anyway. So the lab experiment was similar to this one, a room like that, with 30 people. They were students of economics from the National University of Colombia in Bogota. And every student had written instructions, and these instructions were read aloud with a PowerPoint presentation as if I was the one conducting the experiment. And I'll go you through the summary of those instructions. So individuals had to perform, so if that were the room, all of you would have to perform this contingent grouping task in 5 rounds. So we do it once, we collect information, we make the calculations, we do it twice, the same, 3 times, 5 times. And it will look like that, the card choice. It will have good 1, good 2, and the payment in Colombian pesos. And then the status quo, opt out or do nothing, okay? And 2 alternatives. And I'll show you in a minute what's in there. So quite a standard procedure. Okay, each good was defined by 2 variables, a unit value and the amount. The unit value, so how much you value 1 unit of this good, was given to you at the beginning, different and private. He knows his value, one and the other don't know the other's value, okay, private. Each one a value. And this value for good 1, 2,000 pesos, this would be for the whole day. Okay? This is your value, this is what maximum willing to pay for 1 unit of good 1. Same for good 2, 500 pesos. That's your willingness to pay for 1 unit of 2. And that's it, okay? All the time, for the whole day. Then, if it's a status quo opt-out, would be 0 amount and 0 payment. Okay? Very standard. Then, here, we would change the levels. I think it was between 1 and 6. And also this change from individuals. Then you will have, for instance, in this example, this value for 1 unit, 5 units, so 5 times that. This value for 1 unit only, so this is your value. So both together is your maximum willingness to pay. And here is what you ask to pay. Okay? And this is also, again, like the other levels, assigned differently to different individuals. Same here for the second, we just vary these 3 numbers. So very standard. Nothing different up here. Okay. It's a bit complicated, so I'll explain how this works in 3 slides. This one, and this one. And then I'll ask a question, see whether we understood the mechanism. Okay? So first one, the payoff, what I receive at the end of each round. So the payoff is calculated so that can be positive or negative. And it's the difference between my value and what I have to pay. My value is always assessed at 2 units of good 1, 3 units of good 2. So if implemented, the provision of these goods, if the goods are provided, 2 units of good 1 will be provided, 3 units of good 2 will be provided. Okay? At a given cost, that's going to be determined randomly. Okay, between 2,000 pesos and 40,000 pesos. I'll go to that in a minute. Right? If it's not implemented, then there is no payoff. It's the opt-out, no implementation of the goods, so no gain, no loss. Okay? But if implemented, it's the difference between your value, which depends on what you have been assigned at the beginning, and it's the same for the whole day, and 2 units and 3 units. This is the payoff. Second slide, the implementation rule. The implementation rule is publicly announced, so everyone knows the rule beforehand, before making the choices, and depends on the difference between the value and the cost. Okay? The value is calculated as a mean value. So after we collect, after the third round, after we collect all the answers, we apply contingent grouping. I'll tell you about that later. And then we get the result, the mean of the marginal willingness to pay for each good, each one, 1 and 2, depending on your responses. Okay? So this would be the mean value we calculate out of your responses for good 1 and the mean value for good 2, assessed at 2 units and 3 units. So this would be the social value per person. And this would be the random number, the cost, that we will randomly pick. So if the cost is higher than the value, then no implementation. If the value is higher than the cost, we implement. And the payoff is calculated, as we saw before, different for each individual. So rather standard. Okay, so that's the implementation rule. And last one is how it works. 5 rounds. At the end of each round, we do this, this drawing. So the random amount, the cost between 2,000 and 400, is drawn publicly. We used Excel and from a uniform distribution. Therefore, the mean value expected would be 21,000. Okay, that's the expected mean. So at the end of the session, the individual with most payoffs, first session, we calculate the payoff. Second session, the payoff. Third, fourth, fifth session, the payoff. After the 5 rounds, the more payoff you get, the more money you walk out of the room. If you get a net negative payoff, then you always get, or 0 payoff, you always walk out with 10,000 pesos. Okay, that's the minimum for participating. But you can do better. You can get more if your payoffs are positive at the end. Okay, so that's the rules. That's all we have to know. So with that in mind, let's get an example, see whether we understand what's going on. Let's say Maria has a very low value assigned, okay? Only 50 and 300. It's too radical, no one got that, but just for the example. Therefore, this would be 50 and this would be 300. If implemented, would be 2 units and 3 units. So if implemented, Maria would have a value of 1,000. That's the maximum willingness to pay if implemented. Okay. But when we draw the cost will go between 2,000 and 40,000. I value 1,000. It will cost at least 2,000. Here, if implemented, I'm going to lose. If not implemented, I don't lose. So my incentive is to try it not to be implemented. Right? Because if implemented, I'm going to lose. Because my value is lower than the cost we are going to draw. So in order to contribute to avoid the implementation, if we are Maria, what we should do, what should we do? When we ask to alternative 1 and alternative 2 say whether those are better or worse than the status quo, what should we say? Better than the status quo or worse than the status quo? We don't want it implemented. Better or worse? worse. Okay? So if you say those alternatives are worse than the status quo, then the status quo is better. So the alternatives are too expensive. We don't want them. Okay, too expensive. So this would decrease the marginal values we estimate. So it would be rational to say 1 and 2 are worse than the opt-out, the status quo. And this always, regardless of what's in the cart. If it's a payment more than 0, then I don't want it. Even if I would really want this alternative. But it's in my interest to say no. You see that? Okay. So last example, the other extreme. Let's say Martin has a very high value assigned from the beginning, very high willingness to pay for the goods, and then we'll have a 50,000 benefit value willingness to pay for the implementation. And this goes from 2,000 to 40,000. So always positive. I always would like this to be implemented. So when asked, I would place the alternatives always above the alternative, the opt-out. I would say, yeah, I would prefer the alternatives, the payment, okay? Because this would increase the chances that is implemented, because the mean value would go up if I place those as better. It will go down if I place those at worse. You see the logic? Okay, so let's go to a more normal example. Let's say two people, John and Jane, have those cards. So one has 2,000 and 500, and the other has 1,000 and 8,000. Okay? So we look at the combinations, and we would say one thing. But what we have to look at is not these combinations. What we have to look at is when I says at 2 and 3, which is the implementation. My value is 2,000 and 500. Therefore, I will get 5,500 in value. Okay. And Jane will look at the same. I would say I get 26,000 in value. When implemented, the average expected is 21,000. So the expectation is that John will be in deficit most of the time. And Jane will be in the positive most of the times. Therefore, we would expect, if they are risk neutral, then 21,000 is the cutoff. If they are risk lovers, it's higher than 21,000. If it's risk averse, then lower than 21,000. But in any case, there is a threshold under which you decide either to favor or to penalize the implementation of the goods. And once you have decided, you always have to group the same way. Okay? In this example, John will always say they are not acceptable. And Jane would always say, yes, please, let's go ahead. Okay? Regardless of these maths. You see that? Okay, so the results. 30 students of economics with instructions, and some of the clues when to point them to this direction. Only 2 had, out of 30, only 2 had always the same grouping. So either both alternative better than or both alternative worse too. Only 2. The rest mixed. 1 better, 1 worse, which is not rational in the sense we define here. Out of the 2, one of them changed. Sometimes was worse, sometimes was better. So this was not a strategic behavior. So we are left only with one person who could be a candidate for having realized what the behavior would be to maximize his or her welfare. But when we debrief people after each round, the reasons given by this person are exactly the same than the majority of reasons given by the most of the 30 people. So there is no evidence that this person did that on purpose due to the strategic behavior that we would expect. So what's my point? My point is that even if you have a mechanism that is not incentive compatible, like the one with intervals with banked, unless people realize, people will not engage in a strategic behavior in practice. So even if in theory it's a very relevant topic, I think in practice it plays much less out of this. So the problem, I think, was that it was too complex for people to realize. And this, I think, is true in field experiments for most valuation exercises. Unless it's obvious, like in the zoo case, people don't realize, so they may lie, but for other reasons different than strategic behavior. Therefore, in conclusion, not only a contingent valuation is susceptible of strategic behavior, also other methods, choice modeling, or even reveal preference, which is usually thought that it was immune to strategic behavior. And that an exercise is manipulable does not mean that people will manipulate, because they have to realize, and that's difficult. And the more obvious you make it that is manipulable in their favor, then more individuals will engage in this manipulation. That's what seems to come from the very two extremes, or from the two cases we just analyzed. And even if individuals find it difficult to realize, if they are told in advance, then they may engage in a strategic behavior, as we saw in the train station in my university. Okay? So the word could spread before the survey, and then this would be vulnerable, the survey. So the last thing is a question. Maybe this is a topic more relevant in theory than in practice. I don't know. This is some evidence in this direction. Thank you very much.